Okay, so let's start off with the next set of questions that we have. Okay. Um, okay. A 3 cross 3 matrix M has your trace given as TR is basically your trace. Trace of your matrix is equal to 6. Trace of the same matrix squared is equal to 26. And trace of the same matrix cubed is equal to 19. So which of the following can be a possible set of eigenvalues of the matrix that's given to you? Now, this might seem a little tricky because the eigenvalues are the ones that are given to you, okay? So you're probably going to think that if I have something like, say, A, B, C, let me just put this as A1, B1, and C1, A2, B2, and C2, and A3, B3, and C3, and multiply it again with A1, B1, C1, A2, B2, C2, and A3, B3, C3. This is going to probably give me a huge set of numbers. Okay, so it's going to give me different combinations that I have. So I get an A1 squared, okay, and then I get B1, A2, and then I get C1, A3 in the first term. Okay, and this is not what we actually want, and you'll be confused when you look at this. So when they say eigenvalues, I think you've kind of like written it in a reduced form, right? So basically when they're referring to eigenvalues, you can write it this way: lambda 1 is equal to 0, 0, lambda 1, 0, 0, lambda 2, 0, and then you have 0, 0, lambda 3. Okay, and then you have a lambda 1, 0, 0, you have a 0, lambda 2, 0, and 0, 0, lambda 3. So when you take the product, do you see that you end up getting, okay, so when you take your first row and multiply it with the first column, you end up getting a lambda 1 squared, then you end up getting a 0, 0, then you end up getting lambda 2 squared, 0, 0, 0, and lambda 3 squared. Okay, so here when they are saying that the trace of m squared is equal to 26, they're basically saying that the trace is basically for your m squared, which is equal to lambda 1 squared plus lambda 2 squared plus lambda 3 squared. Okay, so now what you're supposed to do is you're supposed to be finding which set of eigenvalues are possible. So the eigenvalues are already given to you. Okay, so all you have to do is square the eigenvalues, add them up, and check if that matches the trace. Then in this case, you cube the eigenvalues, add them up, and check if this gives you the trace. So you'll have to use the options and check it. Okay, so let's take the first one. So if you look at the first one, when you add them up, you get a 6. Okay, if you take this, when you add them up, you get a 6. You take this, you add them up, you get a 6. All these give you a 6. So you can't rule out that, rule out with this data any of the options. Okay, so now let's look at the one that is squared. Okay, so what do? Okay, so you take 1 squared plus 1 squared plus 4 squared is 16. So that gives you something like 16, 17, 18, right? Now you have a minus 1 whole squared, that should give you a 1. You have a 0 squared and you have a 7 squared. So that should give you a 49 plus 1, which is a 50. So it's not this, it's not this. Let's look at this. So you have a 1 minus 1 whole squared plus 3 squared is a 9 plus 4 squared is a 16. So you end up getting 1 plus 9 plus 16. So is it that? Let's check it out. So you get a 26. What about this? Let's just do it to just rule out. Or if it's just the option C. So you have 4 plus 4 plus 4. And 4 3s are 12. So it's going to be option C. Okay, so you don't even have to cube it and calculate the value. You can finally decide on your option C just with this. Okay. So yeah. So this is your calculation of the trace of the matrix. You square it and then calculate it. And then you can just do this for verification. If you want to check that your options are really correct, you can do a lambda 1 cube, lambda 2 cube, lambda 3 cube and check it out. Okay. So let's move on to this. I want you to be a little bit careful with this because this involves something called a Wronskian. Okay. So I don't think we have kind of like done it in our MSc syllabus much, okay, but let's just look at it anyway. Okay, so let x1 of t and x2 be two linearly independent solutions of the differential equation d squared x by dt squared plus 2 dx divided by dt plus f of t of x is equal to 0, and let w is basically your Wronskian. Okay, so w of t is equal to x1 of t dx2 of t divided by dt. So these are basically the solutions that are given to you. These x1 of t and x2 of t are basically the solutions that are there. Okay, and this is x2 d of x2 divided by dt and d by dt of your x1. Okay, so you're taking the derivatives of the solution. So basically it's like the solution x1 and the derivative of the solution x2, then the solution x2 and the derivative of the solution x1. So that's how you write the Wronskian. Okay, and now they've given you one value of the Wronskian, which is w of 0 is equal to 1, and then the other one of the Wronskian is what we are supposed to find. Okay, so let's just look at how this is built up. Okay, so I'm going to kind of like go through this for you. So in general, for an nth order linear differential equation, if you have n minus 1 solutions, the last one can be determined using the Wronskian. Okay, so now if let's say you have a second order differential equation, so you basically know, if you know one solution, you can get the other solution using the Wronskian. Okay, now let's consider this second order differential equation. Y double prime is equal to a of x y prime plus b of x y. Okay, where you have your a of x and b of x are known to you. Now if y1 and y2 are the solutions of the equation, and the form of the Wronskian is basically w of x is equal to y1 y2 prime minus y2 y1 prime. So basically I think you should realize by now, when you had an x1 of t d x2 of t divided by dt minus x2 of t d x1 of t divided by dt is what you had there as a Wronskian. Okay, so here basically your y is in a function of x. Here the function x is in terms of t. So here your variables are y, x and y. Here your variables are t and x. Okay, so be careful about that. Don't be confused about that. Okay, so now you differentiate this Wronskian, and using the fact that your yi obeys this differential equation, you can come to some kind of a solution like this. Okay, so you have a y prime of x is equal to a into w of x. Okay, this is how you get it. Now your Wronskian basically becomes a simple first order differential equation, and you can exactly solve this. Okay, so in practice you can in theory you can exactly solve this, but not so true in practice. Okay, now your w of x is equal to e to the power of ax, but what is your a prime of, what is your ax? Okay, so basically it should be your integral of this value that's there in the differential equation. Okay, so you should get an integral of a of x dx. That should be the value of a. So a prime of x is equal to a of x. That means this should be the integral of this that you have in your equation, the differential equation that is given to you. Okay, now let's say we know the solution y2. Okay, so you can find the solution y1 by using this kind of a format. So basically here what they've asked us to do is not to find the second solution or the first solution. They've asked us to find the Wronskian's value. Okay, so for that all you need to remember is this. Okay, w of x is equal to e to the power of ax. Ax is basically the integral of this term that you have here. Okay, so your y prime is equal to a of x y prime, y double prime is equal to a of x y prime plus b of x y. Okay, and now the differential equation which was given to you is basically not in terms of y and x and y, but in terms of t and x. Okay, so you have to be careful about that. Now what is the value of ax? So you have to kind of like shift it to the other side and all that. So the differential equation that was given to you is basically this. Okay, in the question. which was given to you was this. So what you need to do is you need to basically shift this to the other side. So you get a d squared x of t divided by dt squared is equal to minus 2 dx divided by dt minus f of t of x. Okay, and this minus 2 is basically your a of x. Okay, but here it should be an a of t. So be careful about that. So a of x here is basically your a of t. So a of t is equal to minus 2. And now we integrate it, okay, integrate a of t with respect to dt, you end up getting minus 2t, okay? So you end up getting a negative 2t here. Now let's look at this, okay? So your Wronskian, which is a function of t, is equal to e to the power of integral of a of t dt, which is equal to e to the power of integral minus 2 dt, which is equal to e to the power of minus 2t, okay? Now what do? You substitute the value of 1. What have they basically asked you in the question? The question they have kind of like asked you what is the value of the Wronskian's value for 0 is given to you, but you need to find the value for 1. So you input 1 and check it out, and you realize that the value comes out to be 1 divided by e squared. Okay, so you get a w of 1 is equal to e to the power of minus 2t. T is basically 1, which is equal to 1 divided by e to the power of 2. Now you can actually, they've given you some amount of extra information, right? Here, so they've basically given you w of 0 is equal to 1. Okay, so if you kind of like substitute e to the power of minus 2 into 0, you end up getting a 1. So that's kind of like a verification that you can, you know, like match it with. But you don't really use this value that in the problem. It's basically just given to you. Okay, so if this is, you just need to find out this Wronskian's value at 1. Okay, so that's basically your option D. Okay, so let's move on to this. Okay, the graph of the function f of x is equal to 1 for 2n less than or equal to x less than or equal to 2n plus 1, 0 for 2n plus 1 less than or equal to x less than or equal to 2n plus 2, where n is equal to 0, 1, 2, 3 is shown below. Its Laplace transform is, okay, so what you need to do here is let's look at it, let's look at how the function basically looks. Okay, so here your n value is given to you as 0, 1, 2 and so on. Now what you do is you substitute each value of n and check out where it's going to be 1, where it's going to be 0. Okay, so your f of x is equal to 1. Okay, let me substitute 0 here. So I end up getting 0 less than x less than or equal to x less than or equal to, I have a 1. Okay, and 0 here, for you have a 0 plus 1, so 1 less than or equal to x less than or equal to 2. So that's what you have here in this figure that they've given to you. So it's like the square function. Okay, so you have a you basically go to a high from 0 to 1. Okay, and you go to a low from 1 to 0, 1 to 2, and then it keeps alternating like that. Okay, so if you end up putting this as a 1, you basically, okay, so let's look at the next term. Okay, so if you take this n to be 1, you end up getting a 2, and here you end up getting a 3. That's what you see here. You end up having a high value, and for the other one, you basically have 3 to 4, which is a lower value. Okay, so it keeps repeating on like that. Okay, so let's look at the answers that are there. Now, how do you write your Laplace transform? Basically, this is how you define it. Okay, so you have L of f of t. F of t is equal to integral from 0 to infinity e to the power of minus st and dt. Okay, so that's how you define your Laplace transform that you have. Okay, so let's, okay, there has to be an f of x2 there. I missed that out. Okay, so you need an f of t dt over here. Okay, so here you have an f of s is equal to integral from 0 to infinity e to the power of minus st f of t dt. Okay, so this is something that is extremely commonly used. Even if you do not know what the Laplace transform of a function is, if you know this formula, you can find out the Laplace transform of that function. Okay, so it comes extremely in handy, and I think this is done extensively in the second set. Okay, so Okay, so this is let f of t be the function defined for all positive value of t, then your f of s is equal to integral from 0 to infinity e to the power of minus st f of t dt. Provided the integral exists, then your f of t, then your f of s is called the Laplace transform of f of t. Okay, so this is what you have. Now you need to calculate the Laplace transform of the function that is given to you. And if you look back, in what terms is the function given to you here? It's f of x. Okay, so you have to be careful about that. It's not f of t like how I've defined it here. It's an f of x. So you end up getting f of s is equal to the integral from 0 to infinity e to the power of minus sx f of x dx. Okay, so that's how the Laplace transform is going to be defined from now on in this problem. Okay, so now what we need to do is we need to take that function that you had. Okay, so if you look at this interval, it's from 0 to infinity, right? And the function kept oscillating like this. From your 0 to 1 you had this, from 2 to 3 you basically had another peak, from 3 to 4 you had another peak. Wait, did I miss something? Yeah, this is 4 to 5. Okay, and it went on like that. Okay, so you have a 0 to 1 e to the power of minus sx into 1. Why? Because it's from 0 to 1, so you have to put that particular function there. Okay, next let's look at this. So you have a 1 to 2, so you have to multiply this with a 0 because it's going down low. Okay, so you have to multiply that with a 0. Next you end up multiplying it with a 1, and it keeps alternating and going on like that. Okay, so now what we need to do is we need to integrate it. These terms will get cancelled, like all the alternative terms will get cancelled, all the other alternative terms will get added up. Okay, so you end up integrating this. E to the power of minus sx is a simple integral, e to the power of minus sx divided by minus s. Okay, so that's your integral for that. You integrate it from the interval from 0 to 1. Okay, and then you integrate, this term becomes 0, you integrate this from 2 to 3, and so on. It goes on like that. So you realize this is giving you something like a series. So then you're supposed to be summing the series up, and you'll see that you're supposed to be using the formula for summation of geometric progression for an infinite number of terms. Okay, not for a finite, but an infinite number of terms. Okay, so now what do? You substitute these limits that are given to you. So you substitute 1 here, so you get an e to the power minus x. You substitute 0, you will get a minus 1. Similarly, you keep substituting this. Okay, remember that this 1 divided by minus s is pulled out. So later what we will do is we will bring that minus inside. Okay, so you end up getting a 1, and then you have a minus e power minus s. Then you have a plus e to the power of minus 2s minus e to the power of minus 3s, and so on. Okay, so that's what you end up seeing now. Now this is a geometric progression. So basically when you have a geometric progression with an infinite number of terms, what do you use? You use this formula where you have s infinity is equal to a divided by 1 minus r, where r is basically the ratio, the common ratio of your geometric progression. So what your common ratio basically is that you take this term and you divide it by this term. Okay, so you can do that for any term that you have. So you have e power minus 1 minus s divided by 1 is equal to e to the power of minus 2 divided by minus of e to the power of minus s. So this should have a minus. You should include the minus term too. Okay, so you should include the negative sign along with that term. So what you realize is you get an e power minus s. When you calculate this too, you end up getting an e power minus s, and that's why it's called the common ratio. Okay, so this is something that we've done extensively in PU, but I'm just kind of like recalling it again. Okay, so now what do you have here? You have basically this is how your nth term will be. Okay, so the nth term is equal to a r power m minus n. Okay, so if you have m number of terms and the total number of terms are n, and you have to find, if your total number of terms are m, and if you have to find out the nth term, you take the total number minus your n. Okay, so here your common ratio is e to the power of minus s with a negative sign, and a is basically 1 divided by s. So if you look at this formula, your 1 divided by s gets multiplied throughout. Okay, and the first term here is actually 1, but since you have a 1 divided by s here, you multiply it instead and you take that first term as 1 by s, okay? Or what you could do is, you could consider this as just this as your summation, but you'll need to multiply it with this 1 by s after you calculate the summation, okay? So after you do that, you take your a, 1 divided by s, that is your first term, divided by 1 minus of, this is your common ratio, minus e to the power minus st, and then you realize you end up with your answer, that is option C. Okay, so let's just look back at the question, and you end up with option C. So you have 1 divided by s into 1 plus e to the power minus s. Okay. So let's move on to the next one. Okay, so this is pretty simple. Okay, you're supposed to use the you're supposed to be basically getting the first few terms of the Taylor series expansion in the function f of x around x is equal to pi by 4. Okay, so these are the different options that are given to you. Okay, so the Taylor series of a real or complex valued function f of x that is infinitely differentiable at a real or complex number power series is basically written like this. So you have an a, okay, which is the point at which you want your function to be found out. Okay, you want a series at that, around that point. Okay, so basically you start off with an f of a plus f prime of a divided by 1 factorial into x minus a, and so on. You go on like that. Okay, so this is your condensed formula that you have. Okay, so f basically your nth derivative of a divided by n factorial x minus a into n. Okay, so your sine x around x is equal to pi divided by 4 is given by, so all you have to do is remember the Taylor series expansion, and then you basically have to calculate your derivatives accordingly. Okay, so just basically be careful with your signs. So what I basically like to do is I like to make a table on the side, okay, so that I can calculate my derivatives properly. So you have an f of x, okay, here. Then let's calculate your f prime of x, which is your cos of x. Then here you have an f double prime of x, which is equal to minus sine of x. So let's just be very careful with the minus sine of x. And here you end up with an f triple prime of x minus cos of x. Okay, now what you need to do is substitute x is equal to pi divided by 4. That's basically 45 degrees. So you end up with 1 divided by root 2, 1 divided by root 2, minus 1 divided by root 2, and minus 1 divided by root 2. Now you substitute all those values in here, and you basically have to pull out a couple of values. Okay, so you basically pull out your 1 by root 2 so that you can simplify it, and then you end up getting this. So you notice that there is a positive here, negative here, negative here. So it's basically going like 2 terms positive, 2 terms negative, then 2 terms positive again, 2 terms negative again. Okay, so I think the reason is that you need to take that sign and differentiate it like 4 times in order to get your sign back. Okay, so that's why there's this 4 intervals of getting, like, you get the positive term after 4 times. Okay, so the repetition is basically after 4 terms again and again. Okay, so let's just go back to the question and look at this. Okay, so basically you see that it's option B that's given to you. Okay, so let's look at this. This is pretty simple. Okay, a vector perpendicular to any vector that lies on a plane defined by x plus y plus oh, this should have been a z. Okay, x plus y plus z is equal to phi is. Okay, so what is that? Now, I think I kind of like discussed one of these problems in the last session. Basically, you were given a surface like x, y, z, okay, and then you had to find the normal to it, and then you had to find the tangent to that normal, okay. So then I think you end up computing the dot product, equating it to 0, and finding that vector out, which is tangent to that surface. Okay, now here they basically ask for the normal to the surface. So all you have to do is take the gradient of that. So let me just specify that this is z. Okay, and let's look at the different vectors that are given to you. Okay, so all you have to do here is basically Okay, so obtain the normal at the surface by calculating the gradient. So for that, what do you have? You have an f is equal to x plus y plus z minus phi, and you basically have to calculate the gradient. So what do you have? You have a dou by dou x, so you'll realize that's going to just give you a 1. Dou by dou y, that's going to give you a 1 as well, and dou by dou z will give you a 1 as well. So this is how you kind of like calculate the normal to the surface. So this is pretty simple compared to the other problem that we did last time. So the other problem, just to kind of like recap, what they asked for was a tangent to that surface. So you had ended up having a surface xyz, and then you took up your normal, and then from the normal you kind of realized that the normal and the tangent are going to be perpendicular to each other, and you took the dot product, equated it to 0, and then found out the tangent's unit vector. Okay, so I will try to do as much as recap so that it's kind of like easier to remember. Okay, so here basically you have something like this, finding the eigenvalues of the matrix. I feel like this is something that they keep asking a lot, like every paper has this question. Okay, so even last time I think we kind of like did this once. Let's just recap and go through it over again. Okay, so that it's like committed to memory. Now what do you have? You have the eigenvalues of the matrix. So what are the ways in which you can actually like eliminate options? Okay, so the first way that you do is the trace is equal to the sum of the eigenvalues. Okay, so the trace of the matrix is equal to the sum of the eigenvalues. That was the first principle. So we add up the values here. What do you realize? It's 14. Okay, so the value is 14. Trace of A is basically equal to 14. And let's compute the determinant of this. So you have 1, 2, 3. I'm going to use the Saurus method. Okay, it's called the Saurus method. I have a 1, 2, 3, 2, 4, 6, and 3, 6, 9. Then I have a 1, 2, 3, 2, 4, 6. Okay, so I take this product. Basically, what do I get? I get a 9, 3s are 27, 9, 4s are 36. Okay, and then I end up getting a 6, 6 are 36. And I get a 36 from here too. Okay, and then I subtract it. So be careful about this. So you're going this way. Okay, this was down, this is going up. So you have 9 4s are 36, 6 6 are 36, and here you end up having a 36 again. So you end up getting a 0. Okay, that only eliminates one option. So that means you have no other go. You kind of like have to do all of them. Like you have to kind of like calculate this using the characteristic equation. Okay, so let's just review those methods. Okay, so these are the shortcut methods. I think in KSAT problems, you can kind of like use these shortcut methods, and they kind of like easily give you the eigenvalues. But here in the net questions, they basically want to check your speed. So I think that's the whole idea of giving us very confusing options in the question. Okay, so let's kind of like do this entirely. Okay, so I will work this out. Okay, so what I'll do is I'll kind of like write this down here itself. Okay, so you need to solve the characteristic equation. How do you do that? Let's put this as basically you have to find determinant of A minus lambda I. Okay, so you have a 1 minus lambda 2 3, you have a 2 3, 4 minus lambda 6, you've got a 6 9 minus lambda. Repeat these two columns again. So you have a 1 minus lambda 2 3, 2 4 minus lambda and 6. Okay, so you multiply this way. So you have 1 minus lambda, 4 minus lambda, 9 minus lambda, and then you have a 6 6 are 36, and here too you have a 6 6 are 36. Okay, now let's do a negative sign into 3 3s are 9, so you end up getting a 9 into 4 minus lambda. You end up getting 6 6 are 36, so 36 into 1 minus lambda, and you get a 2 2s are 4, so that's plus 4 into 9 minus lambda. Okay, so now let's erase all of this. Okay, and simplify stuff. Okay, so you look at this and you have, let me just do this first. Okay, so I end up getting a 4 minus 5 lambda plus lambda squared into 9 minus lambda. Okay, I've got a plus 36 plus 36. I'll just leave it like that. And then I have 9 with a negative sign. I have 9 4s are 36 minus 9 lambda plus 36 minus 36 lambda plus 4 into 9 is basically 36 again, minus 4 lambda. So you kind of like realize the 36s can be cancelled out. Okay, so I've got two 36s. I'll cancel out 2 36. Okay, and now I will multiply this part here. Okay, so I will just erase all of that. I think that's better. So this goes away, this goes away, this goes away, and this goes away. Okay, so now let's do this part. Okay, so 9 4s are 36. This is 45 lambda. This is plus 9 lambda squared. And you have minus 4 lambda plus 5 lambda squared and minus lambda cubed. So that's done. Okay, this is gone. Now what you realize is you end up having 36 here. So I can remove this 36 and this 36. And then what I have is a 49. Okay, so that goes away. Now I end up getting this and this go away. These, all of these go away. Okay, and finally I end up getting a 40 lambda squared minus lambda cubed. So I can pull out lambda squared from here, and then I have a 14 minus lambda. So the eigenvalues lambda 1, lambda 2, and lambda 3 are basically 14, 0, and 0. Okay, so that's what you have in your options. You basically have 0, 0, and 14. Okay, so that's option D. And these are the calculations that I've kind of like done. The first few terms in the Lorentz series for 1 divided by z minus 1 into z minus 2 in the region 1 less than or equal to z less than or equal to 2 around z is equal to 1 is. So the thing about Lorentz series is basically it's used to get the other side value. So you have basically positive exponents and you have negative exponents. So in your Taylor series, you just have positive exponents, right? You have x power 1, x power 2, x power 3, and so on. In Lorentz series, you end up getting another negative set of exponents. So you end up getting 1 divided by x minus a and 1 divided by x minus a square and so on. Okay. So that's the different, that's why you basically use the Lorentz series. Okay. So what you're supposed to do is you're supposed to expand this in such a manner that you get it in that kind of a format where you can write both negative as well as positive powers of just one term. Okay. So let's look at this. Okay, these are the options that are given. So now what I'm going, so basically even without calculating this, I think you can realize that this is basically how your Lorentz series looks. Okay, you have both positive as well as negative powers, but it's kind of like confusing because you have 1 divided by z minus 1 into z minus 2, and you really do not know how you ended up making that into this. Okay, so now what we're going to do is you're basically going to end up doing a partial fraction expansion, and then you kind of like expand one of those terms using the binomial expansion and get it done. Okay, so the Lorentz series of a complex function f of z is a representative of a function as a power series which includes terms of negative degree too. Now, it may be used to express the complex function in cases where your Taylor series expansion cannot be applied. So that's why you end up using your Lorentz series. Okay, so this is how your Lorentz series is given. Okay, so now if you realize that if you look at your Taylor series, okay, let's go back and look at the Taylor series for a minute. Where is it? Yeah, okay. So if you look at your Taylor series, where does it start from? N is equal to 0 to infinity. Okay, so that's where your Taylor series starts from. But if you look at your Lorentz series, it's basically starting from negative infinity. Okay, it's basically starting from negative infinity to infinity. So then you end up getting all those lower order terms too. Okay, so you have an a power n z minus c whole power n. Okay, a, n, and c are your constants. Okay, and this a, n is basically defined with the Cauchy's integral formula. Okay, and what I want you to remember is particularly that this gamma that is there here in this Cauchy's integral formula is counterclockwise. We have kind of like seen an error in one of the case set problems where they kind of like said contour clockwise, I think. Yeah, they said contour clockwise, and most of the people end up thinking that the contour is clockwise, so they put a negative sign. Okay, so I think that was one of the issues we had with the case set problems. Okay, so now what you do is you split this up into partial fractions. Okay, that's the first thing that you do. You split them up into partial fractions. And how do you do that? So you write this. Okay, I will just kind of like work it out. Okay, so you have 1 divided by z minus 1 into z minus 2. Okay, so this is 1, this is 2, and then you write it as a divided by z minus 2 plus b divided by z minus 1. So now you end up having 1 is equal to a into z minus 1 plus b into z minus 2. And now what you basically do is you end up having an az minus a plus bz minus 2. So you have 1 is equal to, minus 2b. So 1 is equal to minus a minus 2b. And since there are no z coefficients here, okay, so you end up having a plus b is equal to 0 because there are no z coefficients here. If you had a z here, you would end up equating it to 1, but you don't have that, so it becomes a 0. Now what you have is you have an a is equal to minus b. Okay, so what you have here is basically you have minus of minus b, right? So that becomes minus 1 equal to b. Okay, so this becomes plus b. So you end up having minus b is equal to 1, and that's how you get your minus 1 is equal to b. What about your a? A is minus b, so you have minus of minus 1, which is equal to 1. Okay, so your a is equal to 1. Now we have this, a is 1 and b is minus 1. So we substitute that here. Okay, so you have a 1 divided by z minus 2 minus 1 divided by z minus 1, 1 divided by 1 minus z. Okay, so now what I'm going to do is I want to write this in terms of a particular quantity, something like 1 minus z. Okay, and why am I doing that? So that I can expand the other one in terms of 1 minus z. So since I have a negative sign here, I can take it along with this term, and I end up getting a 1 z minus 1. Oh yeah, 1 minus z. Okay, and here what I do is I pull out a negative sign so that I get the same term that I have here. Okay, so I get a 1 divided by 1 minus z plus 1 here. Okay, so that whole power minus 1 is what I will have. Okay, so 1 divided by z minus 1 into z minus 2 is equal to 1 divided by 1 minus z minus of 1 plus, I'm taking it to the upper hand. So now what you kind of like have to do is, I think this is a good exercise to actually write down all the binomial expansions. Okay, so 1 plus x whole power minus 1. Okay, so that is the expansion that we're basically using here, where x is equal to 1 minus z. Okay, so that's the expansion that we're using here, and what we find is basically this is your 1 plus x whole power minus 1 expansion. You have a 1 minus x plus x squared minus x cubed, and so on, and that's what you're exactly getting here. So you end up having this term being this whole thing. So you have a 1 minus of 1 minus z plus 1 minus z whole square minus 1 minus z whole cubed, and so on like that. So you substitute that over here and you end up getting, okay, so here what they have basically done is you have a 1 here. Okay, so from this expansion you have a 1, and you also have a 1 in this bracket with a negative sign. So that's why you end up having this whole thing as z. Okay, so 1 minus of 1 plus z is basically equal to z. So this is basically your z, and that's what you basically get here. Okay, so you end up having 1 divided by 1 minus z minus of z plus this, and so on. So I think it's best to like leave it like this. Okay, so why is that? I'll tell you why. Because here if you look at this, you can write 1 minus z whole power minus 1, and then you can write minus 1 minus z whole power 0, and then you can write plus 1 minus z whole power 1. Okay, now if you do that, if you kind of like simplify this, you do not like get that basic definition of your Lorentz series coming up. So I feel like this is the best way to leave it at, but the options are like given in some random way. Okay, so here what we have is we have 1 divided by 1 minus z minus of this. Okay, so it's option B that we have. Okay, so let's move on to this question that we have. Okay, so this basically involves looking at the options and working it out is the easiest part. I think you might have done a lot of these problems in your maths and BSc. Okay, so what they've done is they've given you the real part and they want you to find the imaginary part out. So what you do is you have your CR equations, your Cauchy-Riemann equations. So you have dou u by dou x is equal to dou v by dou y. And then you have dou u by dou y is equal to minus dou v by dou x. Okay, so these two are the things that you're supposed to be looking out for. Now what I will do is I will do the terms for u and then we will look into your options. Okay, so your dou u by dou x is what? Basically you have a 1 plus you have 2x by 2. So that should give you something like an x. Okay, and dou u by dou y should give you a minus y. Okay, so this is what's given to you. Now let's look at the options. Okay, so this is the quickest way to kind of like find out if the the real part and the imaginary part are like for your for this particular value of your u, do you get your imaginary part to be in what way? Okay, so here what we're going to do is we're looking at this imaginary part and differentiating it. So this is basically your v, right? All these are your v's. Okay, so you do a dou v divided by dou y, you end up getting a 1 plus x. Okay, so you realize this is an instant match with the first option itself. If you look at any of the other options, I don't think you end up getting a 1 plus x. Here you end up getting a x, right? Here you end up getting an x, here you end up getting a 1, here you end up getting a 2y. So you realize this is an instant match. You don't even have to look at the second Cauchy-Riemann equation, but we'll look at it anyway. So dou v divided by dou x. Okay, so that is going to be y. And what you realize here is that is a negative. So negative y is equal to negative y. Okay, so this is the answer that we have. Okay, so let's look at this. So do not actually try to find that out. You can find it out without, if you're given the real part, you can directly find out the imaginary part without your options, but that's going to take an extensive amount of time. Okay, and there are different methods that are there to do that. So it's going to take an extensive amount of time. So this is the quickest way to go about it. Okay, so let's look at this problem. Okay. Now, one thing that I want to tell you is if there are things like there is only two things that you can choose out of one. Okay, so let's say yes or no questions. They have a binomial probability because it's either a yes or a no. If you look at heads and tails, when you're looking at a coin toss, you're looking at a binomial probability distribution or a probability mass function. Okay. What else is there? You would have, let's say, true or false. Okay, so those kind of questions that are there, basically they have something called the binomial mass probability distribution function to deal with. Okay, so this is what's given to you. In a series of 5 cricket matches, one of the captain calls heads every time when the toss is taken. The probability that he will win 3 times and lose 2 times is, okay, so the total number of times the toss is going to be taken is 3 plus 2, that's 5. Out of that, 3 times, what is the probability that he will win 3 times and lose 2 times? Okay, so that's what we're looking at. Okay, so this is your, okay, so P basically refers to your success. Okay, I think you might have done this a lot in your statistical mechanics in your second semester, where you have to actually talk about a random walk, going to the left, moving to the right, and you can only move to the left or right, so then you end up having that 1/2 probability there. Okay, so your P is basically 1/2 in case of your binomial distribution, and Q is basically equal to 1 minus 1/2. Okay, and that's going to be a 1/2 too. Okay, so now let's look at this. Okay, so nk basically refers to your nck, your combination that's there. Okay, so here you would have, how do you write this? NCR or your nk. These are the different ways you can write it. And you have an n factorial divided by n minus k factorial into k factorial, that's given there. And then p power k. K is basically referring to the successes, and n minus k is basically referring to your failures. Okay, so this is your probability mass function for your binomial distribution. Now what we do is there are 5 total number of events. Okay, out of that 3, what is the probability that he's successful in getting heads 3 times? Okay, so heads basically refers to your success. So 3 times you want heads, 2 times you want fail. Okay, so I mean, like, what is the probability that you will get that? Okay, not want it. What is the probability that you'll fail 2 times? Okay, so here you have your combination 5 by 3. So let's just write that down. 5 factorial divided by 5 minus 3 is your 2 factorial into 3 factorial into 1 divided by 2 whole power 5 is what you have. Okay, totally you end up getting that. Now what do you have here? So let's write 3 factorial into 4 into 5 divided by 2 factorial into 3 factorial. So I can cancel this out, I can cancel this, I get a 2, I get a 10. Okay, into 1 divided by 2 power 5 is 32, and that should give you a 5 divided by 16. Okay, that's this. Okay, so now let's go on to the last question we have. Okay, a ball is picked at random from one of the 2 boxes that contain 2 black and 3 white. Okay, and 3 black and 4 white balls respectively. What is the probability that it is white? So the immediate mistake that you're going to be doing here is you're going to see this, okay, and you're going to just say, okay, fine, let me take these 2. Okay, so they're basically asking for your white balls. Okay, so you end up taking 3 divided by the first box has basically 2 plus 3, which is 5. Okay, and the second box has 3 plus 4, that is a total of 7 balls, and then you have 4 and you multiply this. Okay, so this is wrong, this is not the way you're supposed to do it. Okay, so basically when we're looking at this, okay, so these are the options that are given to you. Okay, so basically when you're looking at this, you're supposed to be looking at it in 2 different ways. Okay, so let's say you have a box here, okay, and you have another box here. Okay, so picking a white ball from this box and picking a white ball from this box are mutually exclusive events. Okay, picking a white ball from this box and picking a white ball from this box are mutually exclusive events. Okay, so that's what we have here. And what do you have other than this? Okay, so one event that is there is picking a box. Okay, so the first thing that you do is pick a box, and then from the next event that follows is you pick a white ball. Okay, you pick a ball. Okay, not necessarily white. We're looking at the probability that it is a white ball. Okay, so let's look at this. The probability of picking a white ball from the first box is basically 3 by 5. And the probability of picking up the white ball from the second box is 4 by 7. Okay, so when do you basically use the addition rule? So the addition rule is used when 2 events cannot occur together. Okay, so picking a white ball from box 1 and picking a white ball from box 2 are mutually exclusive events. Okay, so sometimes you'll end up having a plus or minus of P W1 intersection W2. Okay, so let's not look at that right now. Okay, so let's just learn it one concept at a time. This is basically a mutually exclusive event. Okay, it's not dependent on each other. Okay, so it's mutually exclusive. So I'm picking a white ball from my first box and picking a white ball from my second box, and what are the union of those 2 events? So you look at the probability of picking a white ball from the first box, and then look at the probability of picking a white ball from the second box, and you add it up. Okay, not multiply it. Okay, so I think that's the first mistake that people make. Next, let's look at when do you use the multiplication rule. If one event follows the other event, that's when you use the multiplication rule. So let's say I am picking one box, that is basically one event. I'm picking the white ball from any one of those boxes, that is the second event. So I'm supposed to be multiplying the probabilities that I can have of those two events separately, okay? So what do I have here? When one event follows another event, I use the multiplication rule. When two events occur together, okay, occur simultaneously but are not mutually exclusive, okay, when they are mutually exclusive, I use the additional rule. When one event follows another event, I use the multiplication rule. Okay, so the first event here was picking one box. The second event was picking a white ball. Okay, so I should have probably written it as picking a ball. Okay, so that's an error that I made. Now, so you multiply the probability of the first event by the second event. Okay, so probability of picking the box with your picking the white ball. Okay, so you multiply those two probabilities. Okay, so these are the two boxes. The first box had 2 black balls and 3 white balls. The second box had your 3 black balls and 4 white balls. Okay, so let's just calculate that now. Okay, so you have a 3 by 5 plus 4 by 7. You do not do this. You do not do 3 by 5 into 4 by 7, like I kind of like showed you 3 by 5 into 4 by 7, like I kind of like showed you before. That is wrong. You do not do that, but you rather add the probabilities up. And then what do you need to do? You need to multiply it with the probability of the first event. Okay, so what you have here is your 1 by 2. There are 2 boxes and you pick one out of them. So the probability of picking any one box is basically 1 by 2. Okay, so that is the last slide for today. Now, if you have any questions or if you want me to repeat a problem, I can do that. Other than that, I think quite a few people have kind of like dropped out. Yeah, one person dropped out. Okay, so let me know if you want me to repeat any question. I think I think everyone are free to unmute. Yeah, free to unmute.